All right, so what happens next week?
It's our last class.
Last class. And you get to take your exam, and all you have to do after that is your project, finish that up, and then the next semester starts. So how good is that going to be? All right, so okay, I will be putting out a folder for your presentation upload, right? And so I will specifically put in what I'm expecting to be in your presentation. So your presentation is going to be 15 minutes. Okay. So account for having to go through your slides, right? So basically the scenario is you're going to introduce the team, you're going to talk about the skill sets that you had, what was the technology that you ended up using, why did you choose the things that you did, right? And then what was the additional functionality that you chose to add, right? Going through the wonderful, here's a list of all the documents that we created out of this, shows some examples of it. You're not supposed to walk through all of the pieces, right? Because again, you guys did the same basic project, but again, talk about the highlights of what took you a lot of time, what was the easiest, what was the hardest, kind of things, right? So kind of also the, what did you learn out of this? If you were gonna start it all over again, what would you do differently besides getting different team members, right? Something like that. Okay. So those are the kinds of things I'm looking for. You are also to then, obviously within that time frame, leave enough time to go through all of the functionality that you have, and then obviously anything that we make you do beyond what you decide to describe to us. Okay, on your turn-in, okay, make sure that you have screenshots of all the functionality that you have, especially if you are not giving me a copy to play around with, right? Because obviously I'm only going to have, the issue with that is I only have your demo and the screenshots that you have, and if I'm looking for something and it's not in there, I can't go and try to find it, right? And so therefore you just get marked down because I don't have access to it. So right, you have to think about those kinds of, yes sir?
Would small like screencast videos work for you as well?
Yeah. Whatever way you are going to be able to present to me what you've done. Okay. Because again, you have to remember, ultimately the scenario is that your grade is based on did you meet the functionality, and you have to turn in all the stuff that you hopefully came up with, right? So you're showing me all your work, right? I don't know that you have done it unless you give it to me. Right? And then at the end, you're also doing a second evaluation after the fact of getting all this done, of how well did your team members do, including yourself, and then how did your entire team do, so you're managing to that, okay? And so again, 15 minutes on that, then any time for doing other things. So again, there's other people that have other exams and other kind of stuff during that couple days around that. So remember, right, is there only has to, the requirement is you have to have a person that's doing the demo, right? So if you have lots of other stuff going on, well, you don't have to be here to do that, right? You're scheduling the work accordingly. Everybody has to participate evenly is the expectation, right? So if some people are doing the demo and this is their only class, well then, right, that's okay for them. You just have to compensate by doing that. So again, you don't have to be here. Most of the time, everybody from the team that's in the area shows up for it, but there is no specific requirement that that happens. So Cooper, you had a question?
Yeah, do you use the word demo and presentation interchangeably, or are they two distinct?
As part of the presentation, you are doing a demo of your product.
Thanks.
So your presentation consists of you going through a series of slides. And of course, what is on slide one of your presentation slides?
Our names.
No. Well, besides that, your picture of your team.
Oh.
You guys have to have your team picture on there, right? I want to see you guys for posterity forever. Matter of fact, I just came across one from my other database class that was interesting to go back and see their smiling faces again as well. So. All right, so any questions on that? So again, there will be a folder for you to upload the presentation into. Again, make sure you have the slides or some way that I see all of the functionality that you are claiming is working, right? So again, you're going to ultimately have to give me a list of here is what's working and here is what isn't working, and obviously see if it's working and it doesn't work, then we've got a bigger problem, right? Okay, so we're looking for the fact that you got all that. So again, make sure as you print out all the stuff that you have images of any SQL that is generated. So even if it's generating in the background because you have a GUI up front that is generating all that, I need to see that what SQL that you're using, right? So, right, you have to remember, right, I'm not going to go searching for all the stuff, right? So you have to present it in a way that's organized. So part of your grade is on the organization and the way that I can find specific things. So the way that I typically do projects, right, is my first thing that I am going to do on yours to determine your grade is I'm going to have picked out 5 things of what I am looking for. So they will be random things, right? So it could be a complete ERD, build ERD, problem statement. I mean, I can pick 5, any things that I want, and I will see how fast I can find them in what you have delivered to me. So what is it going to mean if it takes me a long time to find something?
You turn in a lot of stuff.
Well, you turn in a lot of stuff and
Poorly organized.
poorly organized, so what does that do to your grade? It does not go up, Cooper. That's, I'm sure your teammates will love you for that, right? Okay, so, right, if it takes me a long time to find things, it's not going to bode well for how well the rest of the stuff is going to go. So make sure you organize, so it's labeling, and I know you got it all handled for your team, so don't perfect candidate. Okay, so you're going to have a second upload of all the stuff. You're going to have a separate place to put the presentation material, and the third location is going to be the evaluation that you have to turn. Okay, and the evaluation will be due the night of the presentation as well. Okay, so that's on the 18th, and again, minimum of 1 person from your team, but you can have as many people as you wish. Okay, any other questions on that? All right, so we were talking about the whole normalization process last time, right? So we talked about the fact that there are multiple versions of that, and right, we said that in general, from a database design standpoint, we tend to do only the first 3. Okay. So, what was the first normal form? What was the concept behind that? All the data values had to be atomic. Right? So you were looking for making sure that we had all the data in all locations. So in our example, right, from you as a student, if you had a multi-valued attribute field like phone number, right? We can't have 3 pieces of data in the same field. We have to have a separate row of each one of those, meaning we end up with having redundant data across the board because I have 3 rows that represent Cooper because he has 3 different phone numbers associated with that. Right? The second normal form said what? We would go through and you were looking at the key value of the relation that you had, and every non-key field needed to be fully functionally dependent on the full key. If it's not, what did you need to do? You needed to break up the relation into multiple relations. Okay. And then what was the third normal form? We were looking for transitive dependencies, right? And so the other word for that is you were looking for embedded relations. So relations within a relation. So you needed to be able to pull or extract those out. Okay. So then we had the fourth normal form, which is based on the keys. You're looking for multi-valued dependencies. The fifth normal form was based on the keys. You're looking for join dependencies, right? And there's other ones. So there's a whole set of slides related to that in this section, right beyond the third normal form that we've already talked about. I am not going to ask you about that stuff on the exam. We're not going to go over it in class, but I just want to make sure that you are aware that they are out there and that there is some explanations about those specific things, because I have some other specific performance-related topics that I want to make sure we cover today, and then also kind of go over the kinds of things that will be on the exam. All right. All right, so because you have so much spare time between now and the exam and doing your project, right, we have some additional fun-filled work for you to do. Right? So you are going to turn in to me an assignment that is normalizing some relations. Now, the good news about this is you should have to do this for your project. You need to be able to do this on an exam, so doing this is probably really good practice. Okay? So again, you can do this individually or in teams. So if you guys decide that you want to crank this out as a team project, right, on your team, that's one way to do it. You want to do it individually, that's okay, right? Up to you. Right? I'm not requiring you to do anything. So in our example here, we have a relation that we define called student, right? It's made up of a student ID, student name, student email, and there's 3 instances of the student email. There's 3 instances of the student phone. We have a school ID, a school name, a course, date completed, and a grade. So whoever did this was a really bad starting point, but it's really great if we're talking about normalization exercise. Okay, so your task is to go through this and come up with the 3 different normal forms of what you would have for this. So, in just looking this, what would you end up doing to create the first normal form associated with this? So what tells you we have a problem for the first normal form? Yeah, I have 3 emails and I have 3 phone numbers. Right? Okay, so what you would end up doing is eliminating the instances where there's 3 of each of those, right? But that means that for each of the rows that there would be 3 instances or 3 rows associated with that to keep the values unique. Okay, because we can only have how many instances for each data value? 1. Okay. Right, so what would so in this case, it's hard to read, but the student ID, the course, and the date completed are the composite primary key. So what would you do for the second normal form? You would look and say, is student name fully functionally dependent on the combination of student ID, course, and date completed?
No.
So the answer to that is no. So what is it dependent, fully functionally dependent on?
Student ID.
Student ID, so it should go into with that, right? So we have to break that one off. What about the student email? What's it fully functionally dependent on?
Student ID.
Student ID. But we have 3 of these. Okay, so we have to end up working with that. Okay, what about the phone? Same thing, right? Okay. What about school ID? Associated with student,
Sure.
right? Or I can put it with course. But I'm probably thinking that, given the fact that it's called student, I want it associated with the student. Okay, what about school name? Could be with a student. Okay. Okay. And what about grade? That would be the only thing that is fully functionally dependent on all of it. Okay. Okay. And what would the third normal form, in just looking at this, what would stick out in your mind?
School name.
School ID and school name, right? I really only need one of those with the student because the school ID is associated with the school name, right? So we have that transitive dependency of student ID to school ID to school name. So therefore I have a transitive dependency, so I pull it out. Okay. So you're to go through and come up with basically the relations that you would expect to happen at the end of all this. Okay. So we kind of walked through this one, there is this one, and there is a second one. So there's 2 of these that you end up doing. So what about this one? Okay. So we have customer ID and the salesperson ID are the key to this one. So again, we have a problem in first normal form because we have 3 instances of the order number and the order item. So we end up getting data off of that, right? Okay, again, you're looking in the second normal form of the fact that I have salesperson name, which is not associated fully functionally on customer ID and salesperson ID. So I know that I'm going to have to pull that off. Okay. What would be an example of the thing that I would have to pull off for a transitive dependency?
Building.
Building and?
Probably department.
Yeah, so sales office, sales department name kind of thing, right? So again, we don't have true definitions for this of all the data dictionary kinds of entries associated with this, right? So you're going to make some assumptions as you do this, but what I'm looking for is for you to derive what it would look like at the end of the normal forms, which would be what would you end up building to make this look correct. Yeah.
When normalizing, is it okay to create fields like primary keys?
Yeah.
Yeah.
Right, so in your example that you were just describing here, right, I'm going to end up pulling out building ID and building name into a separate relation. It's gonna need a primary key associated with that, so it's likely to be building ID. Building ID is still going to need to be associated back with the salesperson, right? So it's still has to be there, but now it's as a foreign key, right? So it's gonna have a dashed line underneath it, right? So no, you are going through and reevaluating what your keys are in the process to decide what it is that you're actually going to build. Right? So again, you should be doing this as part of your project to determine what databases you actually have to build. You need to do this on here because this is the type of question that I would expect to put or see on the exam. So you should, if you can do this and what you did on your project, then that should be an easy set of points for you to get on the. All right, so any questions on that? Yes.
Due date
Due date?
for that.
When would you like it due?
May I ask a follow-up question?
Of course you may ask, because I already have a date picked, so it's
Yeah.
already ready.
Are you gonna give us time today to work on this, or is this just showing us the assignment?
No, I'll give you some time today. So when we get done going through all the stuff, whatever time is left, you will be able to work on it. And if it's 3 minutes, you get 3 minutes, and if it's more time than that, you get more time. Right, but I'm going to have this due by the exam because that's the purpose of this, is so you have done it multiple times so that you're able to do it on the exam. So,
So your rooms will give us the answers.
give you the answers?
Oh,
That's funny.
Never mind.
5 minutes before the exam, I'll give it to you.
Oh, yeah, that, that works.
Will you? Okay. Well, I mean, we just basically walked through what the answer is to the first one, so I think, right? But, okay, so think about this, right? Is number one says it has to be atomic, right? So I can't have multiple values like we have in here. So it's, the first normal form is basically rewriting this exactly like it is and taking the 3's off, but you have to indicate now that I would have multiple or redundant data because for every, I have 3 rows that have order numbers on them, right? Well, that means the customer ID, the salesperson ID, order number, order item, right? Those are all gonna be on separate lines, right? So that means that, to Cooper's point, now I have a problem because my primary key is not unique anymore. So I have to select something else that's going to be part of that key, right? So, okay, so I just gave you the answer to number 1, right? So what is number 2? You're taking every non-key value and you are saying, is it fully functionally dependent on the key that you've already identified? If it isn't, you have to pull it out. So in our example here, right, you have the order number. Is order number dependent on the customer and the salesperson. Yeah. Right? And if I was to, in my new world of adding these lines, make order number the key, then I'm not even concerned because that has to be the full key. Right? Now, is order item dependent on the customer, salesperson, and the order? Would you say that is a true statement? Given an item, is that dependent on the order number, the salesperson, and the customer?
I think just order number.
Just order number, right? So, what does that tell you? I need to create a new relation that is based off of order number and order item, right? So you okay with that, sir?
Yes.
Right? Okay. And then what about salesperson name? What's that associated with? Right, salesperson ID, but not customer, not order number. So that means I have to pull up salesperson into its own relation with the salesperson ID as the key and the salesperson name as the piece of data. Right? What about sales office? That would be associated with the salesperson. Okay? So, right? Yes, I will give you the answers, but these are all pretty obvious if you would just work your way through the three forms. Right? And we already talked about the transitive relationships, right? And pulling those out in the third one. So I would have salesperson and their name and their office, and then office would translate into department, right? And department would have a name, right? So you keep breaking it down into its final form. But yes, I will give you one. So yes, Cooper.
What is the soonest that this can be posted to Canvas?
How soon can it be posted to Canvas?
Yes.
As soon as I click on publish. So I'm sure you will not let me leave where I'm standing here until it's done. How's that? But yes, I did not want to just post it out there and then you guys go, oh, what is this? And like everybody panics and. All right, so how about we have it due on Monday, and then I will post the answers on Tuesday, so you have time to look at it. Now, to be clear, right, is just like programming, just like drawing charts, just like writing algorithms, right, yours can be slightly different than mine, and it's okay. Right? We all make different assumptions because we don't have a data dictionary, what it's all about, know the exact meaning of all these things. So don't panic if yours doesn't match exactly. Everybody okay with that? Right? So, right? That's the thing I don't want you guys to get hung up on is there is no one exact answer. So if you give me something that is really close, right, and I can see how you got it, then I'm going to give you full credit for it, right? Whether it's on the homework or whether it's on the exam. Okay, and we're understanding the process around it rather than you have to match exactly. Everybody okay with that? just for you, Cooper, I will do it right now so that you, so, you know, because I know you'll like download it and you'll pay attention and do that while I'm talking about everything else, and then you'll miss the other stuff for the final, and then you'll blame me for that, but that's all right. All right, so the specific thing that I want to make sure we talk about today is if you think about our sequence of what we have talked about in this class. Okay, so from the first aspect, we talked about the fact that databases just represent the facts. Facts about what we are interested in keeping track of, that we're going to use in some way, shape, or form in some application, whether it's just doing queries because we have a question to answer, or whether it's a transactional system where you have online users going against this every day. Right? So, and most database management systems or applications that we have do multiple combinations of things. Okay, we talked about the fact that we have to understand the data, that there should be a complete ERD as well as a build ERD. You need descriptions that happen to be in a data dictionary, all the components around that. We have to understand the language that you have within the organization. All of those things play into the end result of what we are trying to accomplish. Right? And then we have to have some way to access this data. So we talked about using the SQL and using the DDL, right? And the DML to access it, right? We talked about the fact that we have different types of file organizations that go on behind the scenes of what type of data you're going to store, because data is just in some sort of file, right? But we have different file organizations that you're going to have in the way that you are going to go about processing that data and accessing it and making it all work. Right? So you are going through the process of evaluating a specific requirement. You're building out, from a project perspective, a database and some forms to access that data. In the background, you're using some sort of database management system in the SQL to go out and process against that. Okay? But long term, in real life, we have to monitor our performance. Okay? And it's actually gotten harder to manage because of what reason? What about the growth of our data?
It does.
Right? It does. And it grows a lot. Right? Every year we generate a lot more data than we had in history, right? So each year is just tremendously adding to it. And we tend as companies not to want to purge any data, right? So we talked about the fact that if you talk to economists, right, they want somewhere around 50, 75 years worth of data so they can see all of the business cycles and try to forecast what's going to happen, right? But you think about the fact that we didn't have computers that long ago, so right, where are you going to get that data from? We don't, so we keep building up, right? So instead of having systems where we are purging data, we are typically just still in the add mode. So again, the bigger the amounts of data, the longer it's going to take to do all the actions that are taking place on that data. So we need to manage that. So again, what are the types of things that we have to be able to do? We have to update the data in terms of adding, modifying, or deleting the data, right? And we have to do it in different ways. So there's different ways that we expect to do it, and ways that we are going to be doing it behind the scenes and just being asked to do it and doing it kind of one-time actions. Okay? So some of the things that we talked about that are going to help us do that is by creating indexes, right? So we talked about a little bit about that last time, right? And the fact that an index just provides you a way or a pointer to where the data resides. So you think about the indexes that you have in the back of a textbook. They give you a keyword, it tells you what page or what pages to go to. You go to that page and then you find it and then you're fine, right? You didn't have to scan the entire book to find that. So you guys have been using indexes a lot, right? But how many indexes do you have in the back of a book? You have a lot of entries in there, but but we could order it alphabetically, we could order it by topic, right? We have different ways that we can do it. So we actually have that same scenario, right? So again, if you think about the computer world, in general, we are just replicating what we do in our real life. Right? So the idea is that we have a primary index, right? So our primary index, if we are going to create a primary index, is going to be based off of the primary key. Hence, primary index, primary key. You guys should be able to think that out on the exam. Right? Okay. So there is one entry for every row of data that you have, because obviously each row has a key on it. Okay. And in our index, we literally have that key value and a pointer that's going to point to where the physical data resides. Right? So what does that mean? That means I have essentially now two files of data. I have the file that contains all of the full stack of data, right? The entire row that's got all the columns of data associated with it. And I have this separate one that has the key, which could be, right, a single key value. It could be a composite key, right? Something like that, right? So we have that, and the idea is that, right, we're going to store the key values in order in some way. So it could be that we have some sort of tree structure, right? So that's what a lot of database management systems use, right? But other ones we can just have it in one big sequence, right, of data, and we process it that way, right? But basically the keys are the only thing that you are sorting. So therefore, if you are going through and keeping track of and moving any of these data fields around, I only have to keep track of the keys and move the key values, not all of the thousands and thousands of bytes of data that you would have to deal with otherwise. Okay. But what that also means is, right, we are concerned with speed. So that means if we have two separate data repositories, one being the key and the other being the data, the data we don't have to keep in order because we're keeping the keys in order, so we just have that over, but it's in a separate location. And when I look up in the index, I'm going to have to find it and then go to the location in the data. So that's why I have that there's two input-output operations per read or per access. So I have to find it in the index, find where the location is, move to the location that's associated with that. Okay, does that make sense? Okay.
So does the Hadoop systems, the big data application, do they have these index?
Yeah. Because again, right, you have to have some way to be able to parse through this data in some way.
Yeah, but typically they don't have any primary keys defined in the
Right, you don't have a primary key as such, but you have some way that it knows what you're going to, right? So a lot of times what happens is, and especially this is kind of the idea when you talk about like machine learning and stuff, it learns historically what you're using and it will be building these things in the background,
Yes.
right? So you put this out there, so for example, we put data out into Hadoop and we start accessing this particular field, it's gonna go, wait, you have accessed it so many times that I'm going to build indexes off of it. So over time, you actually get better performance. Okay? Because again, you don't have kind of the key structure that you have in a normal database, but ultimately I still have to do it fast. And if I have to do a scan through the entire table, that's gonna be slow. So we typically build them, the Hadoop systems build them on the fly. Not bad. Not here, okay. All right, so what I just want to show you now is basically the concept of the way that we typically do indexes. Okay? All right, so indexes, as we said, typically we have a sequence of data that is going to point to where the data resides in the data repository. So I'm going to have a data repository down here at the bottom, which label it data, and I'll draw some instances here, and I will have an index at the top, and we'll draw a few. So we typically, from a standpoint of dealing with this, is we have what we call blocks. And what are blocks of data? It's just groupings. Okay? And what do you know about your computer when it moves data around? So when it moves data, for example, from your hard drive into RAM. When you go and read a piece of data from a file, it doesn't go out to the hard drive and get one tiny piece of data. It will read an entire block of data at a time. So it brings it into RAM because then it's in RAM and you can process through that faster. Okay. So that's kind of the idea that we have. So we have these different blocks that you're going to move sets of these around, right? And so if we look at this, right, what we would end up with is, say we inserted some values in here, and we'll just make them up in the order that they were inserted into the actual database. As we had 5, 10, 11, 3, 4, and 7. We'll just pick some numbers here. Okay. The way that the index would look is that we know that the smallest number would be a 3, and that's obviously pointing down to the 3 location. And we're going to have a 4, and it's going to point to the 4 location. And we're going to have a 5. And we're going to have a 7. And we're going to have a 10. And we're going to have an 11. Okay. Now, what happens if I come in and I enter a 12? 12 just gets added to the bottom, right? There's no reason to do anything different, because this is not in order. The keys are in order, and what do we have at the end of each one of these? What do you notice? We have an empty spot, right? Why would we have an empty spot? So I can insert something into the sequence without having to move a bunch of stuff. Right? So if I enter a 12, right, the 12 can go right at the end here, and I don't have to move anything. What happens if I enter a 6? The 7 is going to move over, and the 6 is going to go in here, and I don't have to move any of the other ones, right? So when we define databases from an index perspective, we are required to, if we're going to do this performance type of thing, we need to specify how much free space that we want entered into each one of these locations. So what happens if I'm not going to be inserting anything? My free space can be 0. What happens if I'm going to be inserting a lot? I'm probably going to want to have pretty big size. If I'm adding some, not a lot, but not a little, I'm going to, right? So you, as a database administrator, need to determine how it's going to be. Because what happens, right? Now if I have to insert a 9. Right? I don't have any free space in here at all, so now I have to shift everything over and, right? Or I can create a whole new entry down here where a 9 is by itself, or if we're really smart, it's going to be smart enough that it's going to say, oh, I'm going to do a 7 and a 9, and I'm going to make this a free space area to give it room to fill in again, right? So again, there's different efficiencies that we have to do, right? So again, somebody programs this. Okay. So Mark, you had a question.
Yeah, what are the discrete rectangles, what do those correspond to? Is that a block then, or is that
Yes.
is it just,
Right, so each one is a block of keys,
okay, so it's a block.
right? And then outside of this, you have a block of the blocks, right? That say how much gets moved into your RAM at any point in time. Right? So, for example, if each one of these represents, and right, and here it represents 3 keys, right? But in real life, we make these so this represents, for example, somewhere around 8,000 characters.
So would you have like a B tree or something like
Yeah, I
that?
could have a B tree, something like that, yeah. Right. There's different, but some type of tree structure typically, right? Okay, but the idea is that when I have the free space in there, I can expand my tree without having to rearrange all the other nodes in the tree. Right? So that's it. That's the concept behind it. So free space on this, and as I bring in, so if my overall block of the blocks is this whole area, all of this would come into RAM at the same time. And then I can move through those to find out which one. And if it's not in that sequence that I want, then I move into the next one. So if you think back, Mark, I think you're thinking of the 350,
Yeah.
right? Right? You had the different layers,
Yep.
right? So you look at the key value, you said is it in this group? Then I can go to the next level, and is it in this group? And I work my way down the tree to get to the final one that I want. Okay? So yes, that's exactly what you end up doing. Okay. But the point I'm trying to make to you is that we don't just magically put the data out there and it just magically works. We have to think about from a performance standpoint, if you are adding keys, well, how do I keep things in order so that it works effectively? So, in our example here, right, as we created the blocks of keys, we ended up giving free space area to add, so we only had to shift things slightly to keep them in sequence, rather than moving large chunks of data to arrange for that.
When you said 10 there, what's it in that, is that an address?
No, so these are the keys,
Yeah, these are the actual data values.
right?
And
So this 3 would point to here, the 4 would point to this one, the 5 would
So
point
it's
to
like
here.
key value, like 5, comma.
Yeah, so again, this area right here would represent the key value and what location, what address location this is physically at.
Okay. So in the case of, let's say, A, B, C, D, all of that the same way you are going to store that.
Yeah, right? Because again, if I have a string,
Yeah.
I have a character, I have numbers, they all have something that we can compare for ordering,
Yeah.
right? So, and A is less than a B is less than a C, right? And AA compared to AB, right?
Yeah.
Right, we have a sequence that we can order them in.
So now, for example, in one of the cells, we have a series of a big string, which is like 80 characters or 100 characters. So which means that it is going into a lot many blocks. So then how is that going to be stored? So is it going to give a range?
Okay, can you repeat that again?
Yeah, so right now we have 5, 10, 11, etc.
Mhm.
So instead of that, let's say we have a big statement there, like.
Right, so it's a string.
Yeah, a big string. So the index that 3 or 5, what is showing there is it's not only going to point to one address, it's going to point to multiple addresses, right?
No, these are always point to 1. Okay, so you have your key, whatever your key happens to be. So in your case, a string.
Yeah, like a 1,000 character string.
Right, so it could be a 1,000-character string,
Yeah,
right? Okay, but I have to keep those 1,000-character strings in order,
yeah,
right?
okay.
So I'm going to have a ordering for as many 1,000-character strings as I want.
Okay.
Right? Associated with each of those 1,000-character strings is going to be an individual address of where all of the other data associated with that 1,000-character string is going to be located at.
Okay, so if it is it could be in a one very big block which comprises of so
Yeah,
many.
so kind of the way that you want to think about it is, maybe this will answer your question, right? Is in your index, right, I have the key value, in your case, the 1,000-character string,
Yeah.
and then I have a pointer or an address of where all the data is associated with that,
Okay.
right? So over on my data, right, I'm going to have the same key, but I'm going to have all the other data fields that are associated with that. So say my table has 100 columns on it,
Yeah,
in addition to the key, which is 1,000 characters,
yeah,
right? So this is where all of the other data in those other columns reside, right? Here is my 1,000 in my string,
yeah.
and this is going to point to this location.
Okay.
So as, right, these different keys and their pointer, as these get adjusted, and these move, right? Because they need to be in sequence,
Yeah,
right? But in my data area over here, these are all going to stay in the same exact spot because This doesn't change. Right?
And the data area, is that something which you call as blocks?
Did you call what?
Blocks?
Well, they're in blocks as well.
Okay.
Right? So when we talked about the two operations,
Yeah.
right? I first have to come to the index and I have to search in the index to find where the key is,
Right, yeah.
right? Or if it doesn't exist, right? Once I find it, there's going to be a location that I have to go to then retrieve the data. So it's going to move over here and find it, and then it's going to take that data and then it's going to return that into RAM for you to use, because that's what you requested. So, operation number 1, go to the index. Operation 2, find it in the index. Operation 3, use the pointer to go into the data area to retrieve the data. And the fourth operation is return it back.
Okay, now if you update it and it is bigger than this current block,
Right, so now if I'm updating something,
yeah,
right, what you're saying is, go to the index. I have to find the location in the index. Once I find it in the index, I have to go to the data area, and then I have to take what's in my program and overwrite whatever it is in the data area that I'm requesting to be updated. Right, so if I'm doing a select and reading it, I'm going to the index, going to the data area, bringing that into the program.
yeah.
If I'm updating, it's go to the index, find where it's at, go to the data area, update it.
Yeah. So my question is, let's say, to begin with, it had 1,000 characters, then I added 100,000 characters in there, then it definitely will exceed that boundary.
You're inserting
So-
extra characters
Yeah,
where?
so that's the data area that pointer is pointing to.
Uh-huh.
Now earlier I had 1,000 characters, now I put 100,000 characters, so naturally you want to exceed that.
But which place are you adding the characters?
Into that data area. So my data, I'm updating it.
Okay, so let me see if this answers
Yeah.
your question on this, right? So this is a specific size,
Yes,
right?
yeah,
And now you change the size,
correct.
right? Okay. Well, I can eliminate this and rewrite this and make it the bigger size someplace else. And then I update the pointer not to point to this one, but point to that one going forward. So I don't have to change the index and where it's at, I'm just changing the pointer to where it is because it's increased in size.
Okay.
Like if you switch chapters 3 and 4 in a book, you just have to change a bunch of page numbers. You don't have to rewrite the entire index.
I mean, so if you just think about the program you wrote in your intro to computer science class, right? And you created a string, right? And a string is just an object that you have in heap memory. And it can change size,
Right.
right? Well, if in heap, if I have something right next to my string of characters and I increase it in size, the system automatically moves it to a different location to expand it, and it changes the address pointer in my program. Your program doesn't act any differently, it just needs to go to a different location in memory.
Yeah.
It's the same concept.
Yeah.
Okay, does that
Yeah,
answer your
right,
question?
yeah.
Okay. But, again, kind of the way that I want you to think about this is, the good news is the database management system is handling all of this for you.
Yeah.
Right? But ultimately, somebody had to design it to actually do that.
Who wrote that, those things?
Pardon me?
Which that something standard which was written
Yeah,
a long time
yeah,
ago?
all the database management systems managed differently,
Oh,
right? And a lot of it's based off of just file organizations. So, right, so if you, from an operating system perspective, have index files, because index files aren't unique to database management. Right?
Okay.
So database management just said, oh, if I'm going to do this, I can store data in these indexed files that already exist from a operating system perspective. So let me just latch on to and use that as the access method. So yes, it's not, this process isn't unique to database management systems. Database management systems are taking advantage of the use of that. Right. All right, so secondary indexes are similar, right? So, but the key value is something other than the primary key, and it can be a composite key. It's used to speed up searches or queries that are other than the primary key lookup. There's one entry for every record, and we can have what we call duplicate values, right? Okay, on this. Okay. 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 So our primary index had to be what? It had to be unique, right? Okay. Secondary indexes, you can allow duplicates. But what that means is kind of behind the scenes, the system is going to generate a sequence. Now, the issue that you have with this is that you may or may not know the exact order that the system is going to generate those in. So a lot of times when we generate secondary indexes, it is going to do a scan of the entire table as it creates the index. So the order that it will be in is whatever the order is that it was in the data area, which isn't necessarily the order that you want the duplicates in. Right? So if you are looking for specific order for the secondary indexes, you want to, if it has duplicates, you want to be in control of what the key is. If you don't care about the order and you just want to know that it's there, for example, then order isn't going to matter. Okay. Right? So we also have the idea down here in the next line, but let me check. Any questions on that? So we can have duplicates, and the order will be based on what the order is in the data area. Okay. The next one is we can have additional data or replicated data stored in the index. So what does that mean? In our data area, we have, in our example, we had 100 columns of data. Okay. And we can use a primary key to look up some piece of data, and we have access to the 100 columns. This replicated data here says, when I create the secondary index, I want to take X number of columns that aren't part of the key, and I want to replicate them on the secondary index entry. Right? So why would we want to do that?
Frequently retrieved together.
Yeah, if it's frequently retrieved using that key, if I do that, I only need to do one lookup that's into the index, get that piece of data, and then I don't have to do the second one of, once I find that, go to the primary data area to retrieve it. So that's the good news. So I can get it down from 2 to 1. But what's the downside of that? I have duplicated data, so it takes up more space. And every time that I make an update, I have to potentially update it in, not in one place, but in 2 places. Right? But we actually use this quite a bit if there is, as Cooper pointed out, there is, with this one particular key, and it's not the primary key, I need this data. Almost every time I look this one up. Because again, that'll make it more efficient. Yes?
Is there a need to define pointers for everything in a table, or can you just define pointers to the things that you need frequently?
Yeah. So, one, you can actually create something that doesn't have any pointers at all in it.
Useful.
Well, it's got its good and bad points, right? I can have only a primary key, and that makes it always look it up, and I'm always going to find it or not find it, and it's going to give me all of the data. If I need to look it up in a way that is not the primary key, but I look up things frequently enough that I need the access path that's going to speed up all of these lookups, I'm going to create a secondary index to look up that particular thing. If there's lots of associated data with a particular secondary key, I'm going to bring that over onto the key piece so I can do 1 instead of 2 lookups every time. So the answer is always, as always, is it depends on what your scenario is.
But it is technically possible to define just a subset and index those fields or those values.
You are so psychic. That's next.
Okay.
All right, so everybody okay with this? Okay, so a sparse index. This is exactly what Cooper was doing. So I think he just looked ahead and decided to ask about that so he could look at the report or something. Okay.
See, cool.
Right? Okay, so a sparse index is literally a subset. Right? And so that's why it's a sparse index. So it's a secondary index, so it's not based off of the primary key, because I can't have a primary key that doesn't have all the values, or primary index. So it's a secondary index that's a subset of the entire base, so basically off of a key field or a set of fields. Okay. And this also can have that replicated data. So if, for example, you wanted to only have, you had a table of all these students, but I did so many lookups that were only on graduate students, I could create an index that only has all of the graduate students in it. So then my lookups are going to be faster because all those keys that we had in the example over there, I'm only going to have the ones that have the graduate students in it and not every student that you have. So is that what you were kind of asking about, Cooper? Yes or no?
Exactly.
Okay. So we create this. So this was actually when I had to create this sparse index. This was the only time in my entire life that I got to write programs in assembler. Was to create the sparse indexes. That's great. I'm like, assembler? Yeah, I do this all the time. Don't worry about it. I'll get right on that. So, again, the criteria for this would be, I don't want the entire database. I want a subset of it. All right, a clustering index. So a clustering index is where the data in the database will be organized by the values in the clustering index. So obviously we can only have one of these because, right, in our other example, when we drew it, the order that the data area had and the sequence that it appeared in, we didn't care. The pointer just happened to do it, and we were looking at it in the way that we indexed. So this is physically changing the way that the physical data area is going to look. Right? So why would we do this? Right? So the good news is default is that there isn't any, because we don't always have to do this. Right? So our advantage is if you are going to be sequentially moving through the data in a certain sequence, you want to cluster it that way because it's going to bring the data from the database area into the RAM area of your system in those big blocks that we talked about. And if I'm accessing the data in order, then it's going to make my application run faster because I don't have to keep going out and grabbing different blocks to get the next set of data that I need. It's all going to be in sequence. So sequential processing is going to speed up if you have a clustering index. Yes, sir.
Is it one clustering index per table or per database or per relation?
Per relation. Because your data area can only be ordered one way.
So is the keys are like 1, 2, 3, 4, 5, 6?
The data area would be numbered 1, 2, 3, 4, 5, 6 as well. Right. So in our example, right, we started with number 5 and then we had the whole sequence, right? Okay. But if that was a clustering index, it would be sequential in the data area as well as in the index. Right. So again, the disadvantage is reordering the data sequence every time that you do a insert or a delete ends up being time consuming.
Yes.
Okay.
So how much will it bring, is there a size which it will bring up, or, for example, you have 10,000s of rows there. So how many will it pick up at one time? Is there a limit on that?
Okay, so the limit, you have to remember that, right? If you think about RAM,
Yeah.
right, on any machine, you have an area that programs run in,
Okay.
right? You have the area for heat memory, right? So you think about you allocating things in heat for your strings and stuff like that. And then there's the buffer area that it moves data in and out from your screen, from your USB drive, from your hard drive, right, wherever. It brings it into RAM and then you process things from RAM, right? You don't ever process anything directly from any of the external locations. It has to be run into RAM and then everything's processed from RAM.
Right.
So when you tune your buffering areas, you can change the sizes to be what you want it to be. Okay. And we have what are called a blocking factor. So the blocking factor is how many records will fit into the block that gets moved from your drive into RAM. Okay. So if I'm bringing 64,000 characters and right, I have 1,000 characters per unit, my blocking factor is 64 because that's how many I'm going to bring in at a time. Okay. But if each one of the things I have is 32,000, my blocking factor is going to be 2. Okay. So it depends on what the size is that you're actually moving at a time, how big your units are that are included in that, you could factor the fact that if I'm going to, for example, have clustering, I'm going to potentially want free space in the data area as well as in the index, so I don't have to keep moving stuff around. Right? So how many you actually get? Our two favorite words? It depends. Right? So in some of mine, for example, I had when I had a clustering index, I had in my data area, I had started off with a 50% free space. Because I was going to have lots of inserts, and I don't want to keep moving all this data around. I'll move it within a block, but I don't want to have to create new blocks, right? Things like that, right? So I started with 50% in my data area and also 50% in my index area. Right? But what that meant is I'm only getting 50% utilization as I'm moving these things in until we get through a bunch of inserts. But what I gained was I didn't have to move stuff around and create new blocks and things like that, or split blocks because they got too full, stuff like that. Okay. So there's trade-offs always. Okay? So blocking factor, how many units of a particular size will fit into the overall block that you're moving at a time.
Does this apply to this big data, these things? Do we specify any of these? Because I understand in the relational regular databases, we can specify a lot of these kind of things, the blocking factor.
Yeah, so typically like in the big data area, you're not doing that because that is more unstructured as opposed, relational is very structured. Right? So your big data is taking a different approach to put data in and access the data, but it's still moving things around in blocks because that's what the underlying operating system
But
does.
you don't have any control.
But you don't have the control over it. But it's using the techniques that it's learning of how you are accessing the data and processing against that and making adjustments. So just like we talked about when you did your SQL, that you were going out and it would go against the metadata to determine what is the best access route. Right? So when you would write a query, it would go into the optimizer. It would then look at the metadata and say, do I have a exact match on a index? If it does, I'm going to use that. Because you don't specify which one to use on your select. You just say, I'm selecting off of these columns, I want these columns from these tables, and here's my conditions. Right? So you're not saying, I want to use index A, I want to use index B, right? So it is behind the scenes looking at the metadata to determine which one you want, or which one it's going to use. And it can then also say, well, a index will get me part of the way there. It doesn't match everything, but it gets me part of the way there, so I'm going to use that as my access. Right. So, again, our relational operates very differently than our big data, but relational is still by far the most popular way that we access data today. So that's why we have a separate course for the big data, and then this is really concentrating more on the relational type of stuff in here. Okay, so again, advantage, sequentially moving these big blocks at a time, sailing through them, and as opposed to, but the disadvantage is when I do these inserts, right, I have to reorder the things, and the mitigation for that is the free space that we put into place to handle that. So again, any questions on that before we move on? All right, so the table scan, the dreaded table scan, right? So this is where we have a particular query in which the access path does not map to a full or partial key in one of the indexes. So what does that mean?
Really fast.
Yeah, it's really fast, right? Because it's going to go, it doesn't look at any of the indexes. I'm going to go directly to the data area and I'm just going to look at every single one of them. Does it match? Yes or no? Does it match? Yes or no? Right? So you get a nice round number like 2 billion rows on your table. It's great. It's really fast. Right? So good news is a lot of times you do table scans, you get to go lunch, come back. Oh, it's not done yet. Go for another snack. Right? So some of our scans have lasted for longer than a day, just because of the amount of data that it has to go through. Right. So we have possibilities of creating indexes. There's ways that database management systems come back and make suggestions on indexes. Right. Okay. Again, the database administrator's job is to kind of manage all of this. Okay. So what's the good news is we have indexes. The bad news is you can't have lots of them. Because again, what happens every time that I have an index? That means every time that I do an update, I have to see whether my indexes change. On a insert and a delete, they definitely change. Right? On a update, it may not change the primary index, but it could be changing any of the secondary indexes. Right? If I have a clustering index, right, we have, right, so point being is that we spend a lot of time updating on inserts and deletes and updates every time that when we have lots of indexes on our tables or on our relations. So again, typically if you end up going above 5, you're going to be in trouble, just from a performance standpoint. Even 5 gets really close to the limit depending on how much data that you have in each one of those. Right? So we tend to make sure that we are 5 or under, and if we have lots of data or lots of keys, things like that, duplicated, replicated data, we even lower the number from 5.
Let's say you have a table which you just don't update. For example, you just insert a lot of records. Every time you insert a lot of records, and you define a lot of indexes, will that affect the performance?
Yes. Because again, every time that you do an insert,
New
you,
records, not the,
pardon me?
I'm inserting new records, not
Yep.
the,
No, but every time that you insert a new record,
yeah,
you're updating an index.
right, but the insert will be affected, but from a read standpoint, will it be affected? Will it be better?
So it depends, right? So again, the indexes are there so that your query process on future inserts, updates, and deletes are faster. Right? So indexes come with the trade-off though, right? So on a insert, I have to go back and update if I have a primary index, I have to update the primary index. I have to have inserted the data into the data area. Then I have to go and validate, do I have to put it on all of the subsequent secondary indexes? Okay. And I'm going to have to do that on every insert I do. Right? So the way you have to think about it is a lot of times our data is so big that we're on different machines. Right? So I have a number of databases that they are so big that the data area themselves are on 10 or 15 servers. My indexes are on individual servers. Right? Well, that means every time that I do my updates, it has to go to different machines to perform all of these updates. And it may or may not do them simultaneously. Because in general, right, you have to understand that what happens when you do an update,
Just of the index.
right? This is that unit of work. It has to do all of the updates or come back and tell you it can't do any of them. Right? So, depending on how sophisticated your database management system is, it may be able to do all of these updates in parallel and keep track did they all work or not, be able to undo them if they didn't, or a less sophisticated one is going to do them sequentially. Right? The issue with doing them sequentially is it's going to take more time. Right? But doing them all in parallel complicates the management of it in terms of what happens if there's a problem. So again, you always have these trade-offs that you have. So did I answer your question?
Yeah, I understand, I was really thinking about just inquiry. Insert, I don't care because it can take one day or
Right.
two days. Yeah, but-
So inquiries using indexes are, if you use a full index, is always going to be fast.
okay. And we can add any number of index, it can just help you. It won't.
No, but again, right, the inserts on a number of indexes is going to be your downfall.
Yeah, that's, I mean, if I don't care about that, then I'm fine with.
Right.
Okay.
So you are correct. All right, so we have direct versus indirect access. Right. So when we talk about indirect access, we are talking about the fact that we are going through an index that doesn't have the redundant data on it. So indirect means I'm going to the index, I'm scanning through, for example, as Mark said, a B tree to find what I'm looking for. Once I get it, I use that key value to go back to the other location in the data area. So it's indirect because I have to go to the index, then go to a separate location to actually get the data. Okay. So that's fast when I have to do the queries and things like that. Okay. Now, where this kind of drops or fails us is that, right, if I'm going through an index, I have a sequence that I'm looking at. Right? I can scan through, for example, an index, and in our example that we had, I can get the exact sequence or the ordering that the data is going to be. Because the index has it in that particular order. Okay. So again, our trade-off is I have this additional storage, the database management system is managing the order of the index, I can read through the index and get the data, so I can process things in order. Okay. Then we have direct access. So direct access is where I'm literally using the idea of a hash key to go to a location. So I may take my 1,000 characters and it turns it into a single location. And then I just go to that location and I grab my 100 columns of data. The downside of that is there is no sequence. I can't say give it to me so that I get 1, 2, 3, 4, 5, right? Because it's randomizing through the hashing key where I go to. So there isn't a direct order that is going to happen. So a hash function is a function that transforms a key to an index, and we have a hashing the key example. So in our example here, that's obviously a very simple one. You take the key and you do a modulo of it to 100. So what does that give you? So the modulo operator gives you the remainder, right? So I have these numbers, and this is going to give me a value between 0 and 99. Well, that's great if I'm only going to get values that where there is only one thing that ends in a 99 or one thing that ends in a 72, right? Okay. So the idea is that we got to be really smart when we come up with our hash key. Right?
Are you gonna want us to do this on the exam?
Pardon me?
Are we gonna be doing this on the exam?
What a great idea. I hadn't thought about that, but that sounds like a really great idea. Right? Okay, so this function simply returns the last two digits of the key for particular key hashes to that location. We store the key in that record in, right? So you think about an array, right? So you guys might have even done hashing functions back in your programming classes, right? Know what it is, right? Strategy does not store the keys in sorted sequence, which means it's applicable only if there's never a need to retrieve them in a sequence, right? So we just talked about that. Okay. So if necessary, right, we have to do one of the previous things. Okay. So if no two keys hash to the same index, this method works really fine. Okay. However, this is rarely the case when we have lots of keys. So for example, if there are 100 keys and each key equally likely to hash to each of the 100 indices, probably no two hashing keys to the same index is, that's not a really good number. So it's almost certain that at least two keys will hash to the same index. So such an occurrence is called a collision, or what I like, the hash clash. Hey, I didn't come up with it.
No,
Right? Okay, so there's various ways of resolving a collision, so we'll talk about some of these things. So one of the best ways to handle collisions is through what we call open hashing or open addressing. So with open hashing, create a bucket for each possible hash value, place all the keys that hash to that value in a bucket associated with that. Right? So the idea here is that in our example, we said that we're going to take the last two digits. You go to that location and it points you to a list, and the list just says go through the list at that point. So then you do a linear search after that. Yes?
When you're doing open hashing, so you basically have these linked lists that, you know, you could go, number of buckets, well, it's number of buckets divided by the, or the total number of things that you have divided by your number of buckets. So that's like the depth. You can go down potentially like an average depth. You can go down on a bad case. It seems like doesn't using a index that is just in a tree or something like that, eventually doesn't that just perform better? Or how do you balance the two items? Do you see what I'm asking?
Yes. Okay, so the way that you want to think about this is if you need things in sequence. Okay? So I process things as a batch. I just want to process all these things and I'm going to do them in a specific order, right? It's always better to use indexes because you already know what the sequence is and I can be working my way through the data area, right, or through the indexes one at a time, right? Because the index already has a sequence that it's using. Right? Where you want to use this hashing type of thing is, I just want to access Mark's record. I don't care about anyone else. I only want Mark at this time, and good enough.
Right. That
Right.
makes sense.
Then, you know, an hour later, I want to deal with Kendra's record. It didn't matter that I looked at Mark before, or in the future I'm going to look at Cooper, right? I only care about Kendra at this point. So this works really well if you only want one thing and one thing at a time. So if the only time that you want to process things is kind of in a real-time environment where you're processing one and only one thing at a time, this is going to be the fastest way to do it because you use this key to calculate it. So like you said, 1,000 characters can, right? You go through and you add up all the values of every single character in 1,000, then you do a modulo, and off you go to a location, right? So it could be something really simple like that, right? So that's going to be really fast. But if I come in and say, oh, I have to process all this stuff tonight, and I have Cooper, Kendra, then Mark, that I'm going to do them in that particular order, right? Then an index where I'm going to work my way through the sequence is going to be faster because I'm pulling those blocks of data in the index in, and I'm not going to have to do as many I/O operations. So it depends on what your action is going to be. Okay. All right. They say it's one of the best ways, but we don't use it. So it's not really one of the best ways, but they claim it is. But okay. So again, the idea here is that we have a set of values that it's going to hash to. You go to that location, it then points you to another location, and you go through some sequence, right? But again, what am I doing at that point? I'm doing a calculation. I'm going to a location to get another location, right? So I'm doing all this indirect stuff, and all of the indirect things takes time. So I like that they claim it's the best, but I've actually never used it anywhere. Right? So again, the bucket doesn't need to equal the number of keys. The more keys you store, the more likely to have collisions, right? All this kind of stuff. So right. It's nice that they talk about that. Right? But again, the idea here is now I have to do a sequential search against all the things that are in that particular spot, and oh, that's going to take time. How much time do you want to wait for something? 0. You want it to already return it before you even hit the click, right? If only it was smart enough to do that. Right. Yeah. So let's just look at some of the other things, right? All right. So in general, the way that we want to think about this is we have a linear action. So this is actually called linear probing, right? And the other one that we have is an overflow. Okay? So what linear probing is I go to a location and oh, something's already there. So then I just move to the next location after this and say, is there something there? Oh, there's something there. Let me move to the next location. Okay, so I go to a location and then I start linearly searching for what the next one is. Right? So put it in the next one, right? I look forward in the linear method. If it's when I go to the original location and it's not found, I keep looking till I potentially find it, which could be a really long time. Okay? And what happens when I put it somewhere else in this linear sequence? Now I'm taking up a spot that I could hash to, and oh, it causes a collision when I wouldn't have if there wasn't something, a earlier collision. So it can cause other collisions. That was what I mean by that one. Okay. Okay. The overflow. Okay. So in the overflow scenario, we only place the data into the data area if it's empty. If there's a collision, I go to a separate area. So I link the spot from where it should be into the overflow area, and then I do a linear search there. Okay, so we'll see an example of that. Okay? So any collision is in a linked list in the overflow area, and the linked list that we are creating is called a twin chain. Because they all go to these same locations, so therefore it's a twin. How nice. Okay? So if we kind of flip back to our director over here. And all right, so in this one, instead of having the data and the index, I just have one giant area. Okay? And so what happens is at the very beginning, when you create this, you say, I want this area to be this size. So you get to pick the size. And then what happens is you're picking a hashing function that is going to calculate an offset into this area of where the data would go. Okay. All right. So if we were to come in and we might have a value where the location for 5 is going to be here. Right? The hashing key for the number 1 is going to be up here. Right? The 37 is going to be over here. The 25 is going to be down here. Right? They're just going up. They're just randomly going to different spots based on the hash key value that you have. Right? So the good news is so far they've just kind of randomly going about, and we've been able to insert them anywhere. Okay. But let's say that we get a value of 15 and it calculates to be the same location as the 5. In the linear method, it's going to say, oh wait, a 5 is already there, so I'm going to go right next to it and I'm going to put the 15. Okay. I come and do a search for 5 or for 15. I come to the location and say, oh, it's a 5. Let me look next to it. Oh, there's the 15. I come in and I say 105. It calculates to the 5. Okay, I can't go there because it's in use. Oh, there's the 15. It's in use. The 105 is going to go next. I come and do a search later for 105. It looks at the 5, goes, oh, it's not there. Looks for the 15, and right, so it's right. But now I come in and I get a 42. And it calculates to this location where the 105 is. Oh, I got a collision. So now I have to go over here and the 42 is in the wrong spot. Right. I get 102, and it's where the 42 is going to be, so it's going to place it next to it. Okay. Right. So again, I can end up getting this cascading effect of collisions because I keep putting it all in the same area where the data should be going. Okay. So that's the linear approach. So we typically don't do that because we end up with way more collisions than we want. Okay. So the way that we typically do it is the overflow scenario that we talked about. Okay. So again, we have our primary area where we had the 5 and we had the 25 and we had the 37 and we had the 1, right? So we had all the ones that we originally had, right? And we said, oh, we want the value of 15. And 15 calculated to be where the 5 was. So instead of putting it linearly, we put it down here and in the overflow, we have 15. And then we came in with the 105. It goes where this is, the next one over here is going to be the 105. The 42 is then allowed to be in its proper spot because we don't have a collision. Right? The 102 goes into its spot because there's no collision.
But how do we know 515 is in overflow?
The what?
How do we know 15 is in overflow area?
Because when I used 15 and calculated where it should go for my hashing function, I found a 5.
Yes, right, but now when you are reading back, it will reverse it, right? It will go to 5, but what in that?
No, you're always going forward. Right?
Okay,
So you're requesting a 15.
yeah,
It calculates out to where a 5 is.
right,
Right?
yes,
I go and find a 5 and say that isn't
yeah,
where it's going to be. So I need to follow the pointer that's in 5 to get me to the next thing in the chain. So it's going to find the 15.
that pointer is pointing to overflow location.
Yes. Right? That's why I have the arrow there. And then, right, the 15 is going to then point to the 105. Right? I'll get you a second, Mark. Right? So if I had 1,002 and it went to where the 1 or 2 is, then, right, 1,000 is going to be here and this is going to point to this one.
Oh, and then if you had.
Right? If I came in with 1,005 and it went to where the 5 is, this is going to point to 1,005. Right? So, right, I go to the original location. If it's not the one I want, I then sequentially follow the twin chain till I find the one that I'm looking for. Does that make sense?
So I have a question. So
Mhm.
let's say you have, so from the 102, you're going to the 1002?
Mm-hmm.
So like what if you have like a 202? Would that 1002 point to the 202 even though it's left?
Yeah.
Yeah, it still would.
Right, because again, think of the scenario that we're talking about. Right? The key is hashing to a single location,
Okay.
right? And then there's no order after that,
Oh, okay.
right? Right? Because they are all equal because they should all be at that same location.
Okay. Alright.
So that's why it's a twin. They're all the same. And I just follow sequentially through to find the one that I'm looking for. Right, so,
So it dynamically allocates the memory based on the size.
okay. Now, so everybody understand the way that this is working? Okay. Okay. So our scenario that we're looking at here is too big versus too small or just right. Okay. So what's it mean if I create this really big giant area? I'm going to be able to hash into it and I'm never going to have a collision. But now I could be wasting a whole lot of space, right? Because I made it so big that I have 0 collisions.
So your hashing function will be like 1,000.
Yeah, I mean, ours like this cover multiple servers, right? So, and it's not I can fit 100 records into this, right? We can randomize or hash probably 5 or 6 million records into this with no collisions.
So do we choose that number or is it?
Yeah, the database administrator is choosing the number, right? So for me, what I would do is I would say, okay, give me an example of your keys. Right? And then I would pick a randomizing function, and the randomizing function has to randomize into the area that you specify. So I would run through the key generator, the hashing function, And then based off of the size, I would then do a frequency and say, how many of these came to the same number? If it came to a large number, it wasn't big enough. If there was 0, then I would have to say, is it too big? Right? So I would do kind of this pre-work simulating what it would be before I actually went and did it. Okay, so too big means there's no collisions, lots of extra memory, so obviously cost, right? Too small means I'm going to have these really big, huge twin chains because I have all these things hashing to the exact same location, which means now my lookup time is going to increase because I have to keep doing these linear searches. So that's bad. Okay? So just right means I'm going to have some twin chains. But if I only have 5 or less kind of on my twin chain, it's going to be really easy and really fast to look through 5 or 6 things. So that means I'm pretty close. Okay. So Mark, you had a question way back
We
when.
answered it.
Really?
Yeah. Although, maybe a little bit more clarification, does the overflow space basically act as a linear hashing space?
In a sense, because that's where I can only get into that because I had a collision.
Yeah.
Right. So if there's no collision, there is no entry into the space. Right. All right, so what could possibly go wrong with this? Right. So you make your initial assumptions, you put stuff out there, and all of a sudden you get an influx of data that you didn't expect, and now my twin chains are huge. So now you go, I'm going to reorganize this and make my area bigger. I've had to do it lots of times. Okay. What do you have to do? I have to be able to get all of the data out, make it bigger, and then put it back. Because what happens if I just leave it? My hashing function is going to calculate a different number because it's off of a different size. Right? So if we go back to our example over here, right? Okay. If I say, oh, this is getting full and I'm now going to make it this big, so this line isn't here anymore. If I haven't moved these things and my hashing function as part of its calculation, this size, I'm not going to find 1 here anymore. 1 is going to technically be over here, and it's going to say, oh, it doesn't exist. What do you mean it doesn't exist? It was there yesterday. Right. So I've had a number of times where our administrators have literally changed the size without pulling all the data off and repositioning it all back out. So you have to understand, when I change the size of this kind of stuff, I have to reorganize the data, which means unload it, reload it back. Okay. We also do that with indexes, right? So what happens if I unload a index or delete an index and I rebuild it? It's going to repopulate it based on the data, and it's going to put all that wonderful free space back in. Right? I'm not reorganizing the data area unless it's, because it already should be in order, even if it's clustered. But I rebuild the index and it puts the free space back in. If I have a clustering data area and I reorganize it, I'm going to put the free space back into the data area as well. So from a performance standpoint, the database administrators are monitoring this stuff all the time. Because what happens if I have really long twin chains? My performance is going to slow down. If I have indexes that don't have any free space, everything's going to slow down. If I have all the free space in my data area filled up, it's gonna slow down, right? I have all these things that bad things can happen. Right, so we need to manage that. Right? Right, so too big, too small, or just right. All right, so cursors. Right, so cursors are the idea that we have multiple rows that are going to be returned from a query. We want to process them one at a time. So typically this is within an application. So again, I go off and I say, give me all of the orders from today. And I get Mark, Kendra, and Cooper's. We store them in a temporary area. We fetch the data out of the cursor one at a time. Right? So just like you can hit the end of a database where there's no more records out of this temporary cursor area, I can fetch things one at a time and hit the end. So you want to think about it as building a temporary file. So I can read through it for as many records as I have. I can do a count on them. I can loop through it. I can go till I get no more records, right? There's lots of different ways to code for this. Right? And the reason that we typically do this is because we are processing these independently, which means we're not locking any of the data. Because this is all internal into your program. Okay? So we talked a little bit about locking on updates, right? So we talked about doing it at the field level, we talked about doing it at the row level, we talked about doing it at the block level, and we talked about doing it at the table level, right? So locking it means nobody gets access to it until what happens? You do a commit, right? Or you do a rollback and undo everything that you did to free it back up because you didn't complete the unit of work. Okay. So basically, locks are we're locking all the other users out. Okay. Now we talked about the fact that we could bypass this by doing a uncommitted read. So what was that about? I go, I don't care whether you have it locked, just give me the data, right? So again, we typically do this when updates are occurring on data fields that we don't care about. So out of the 100 fields on the table, you have things that are updating 25 of those during the day. I want access to some of the remaining 75. Nobody's updating that, it's not changing, just give me it, I don't care if somebody's got it locked. Okay? So, you don't want to do uncommitted if you are doing things with the fields that are being updated, but we have lots of times that we don't update all of the data fields at any given point in time. Okay? All right, so just a quick couple of notes on backup and recoveries. Right? So we have the concept of full backups and incremental backups. So obviously, what's a full backup? I get an exact copy of everything that's in the database. I put it someplace else. Okay. And I have what's called an incremental backup. So an incremental backup is, I have taken a full backup today, and I'm going to take an incremental backup tomorrow. So I'm only going to back up the blocks of data that have changed between yesterday, or between today and tomorrow. The next incremental backup is from the point in time that I did the incremental backup tomorrow versus the one that is on Thursday. Okay? But what that means is if I have to do a recovery, I have to recover to the full backup, then I have to apply every one of those incremental backups to get me to the point in time, and then from the last incremental backup to the specific point in time, I have to then look at the database logs to do things, right? So as we talked about, the database logs is keeping track of every action. A before image and a after image of every action that is taking place. Because again, what happens when you are doing updates, but you haven't done a commit? In the log, has before and after images of all the updates. If you do a rollback, it has to read backward through the log to find the last time that you did a commit, flipping them the other way around. So you've done them and then you undo them. You literally are doing it physically on the database.
When you do that, do the pointers, all of those change? Everything goes-
That's why you're locking everybody out when that's happening, because if you haven't committed it yet, it could be undone. So we don't want people, as you're in the middle of an update, you may only have updated pieces of it. Right? So you want the entire unit of work completed. Typically, it's on multiple databases, so if you've updated one database but not the other, right?
Yeah, while you're rolling back, while you're saying reinstalling from the backup, will all the pointers, everything gets reorganized?
No, you're gonna put back because it is using whatever the backup, type of backup that you have,
Yeah.
is putting the pointers back to the way they were at that point in time. Right? So you have to remember that, right? Your backups are taking snapshots of the data as it was at a point in time,
Right, but
right?
is it not writing back again, instead of starting all over and writing back again as opposed to getting a picture of the pointers? You know what I'm
It's
saying?
using the images of the pointers that you had at a point in time and writing them back over.
Oh, okay.
Right. Now, that's where you have to make a decision, right? So in the example where I've had backups of the databases, it's been easier to unload the data because my indexes were corrupted,
Yeah.
right? So it's easier just to rebuild all the indexes rather than do a recovery of them. Right. Okay. So you have to make a determination of when and how you actually apply those kinds of things. Because there's different ways to do that.
Okay, so when you are recovering or when you are reinstalling from a backup, it is not the same as getting all the backup files, getting all the data and reading it through and inserting back into that. It's not that. It's basically getting the pointers.
Right, so there's different ways to do it. So one way is you literally make copies of everything, and pointers and all. Right? Other backups that we do is I just unload the database. So I get a sequential file that just has all the data in it,
Actual data.
actual data, because if there's a problem, instead of recovering the data and doing all the pointer things and all that kind of stuff, it's just easier to delete it and reload the data.
Okay. Okay.
So it depends, again. Okay. So there's plenty of options. The point is that you can either be doing a full recovery to get the data back to what it was at a point in time, right? Or I have to get it loaded and then move forward to a point in time using the database logs.
But when somebody says recovery, it doesn't say which strategy do they adopt. That's not clear.
Right, typically the data, so for me, I had different types of strategies depending on the different types of databases. I didn't apply just one. It was the different types of data, how often it was being updated, who was updating it, when it was available, what the size was, right? So I had instances where if I was to do the incremental backups and all that kind of stuff, apply, it would take me a week to recover everything. Well, I can't be down for a week, right? So I have to come up with a different way. So that one was, okay, it's just gonna be easier to unload the data at a point in time and just wipe it out and rebuild it
Okay.
than read through all the logs to get me to the point where I'm back to where I was. And other ones, right, especially things that don't change, I just made a copy once a month, and then it was small enough that it would be less than a half an hour to recover it if there was a problem. So that was just a full backup. Or right, incremental ones that I would do daily because there wasn't really a lot of updates.
So when
So-
you say incremental, is that an image or is
You,
that a
it's
data?
you take a full copy, so you take a copy, a full copy on Sunday morning.
So that's
And
the
then,
data or
on-
the image?
right, that's a full image.
Okay.
And then on Monday, I just have a list of, here are all the things that got updated on Monday.
Okay.
And then I take one on Tuesday, here's everything that got updated on Tuesday. I have a problem on Wednesday. I restore it back from the full copy on Saturday or on Sunday morning. Then I apply all the changes that happened on Monday. I apply all the changes that happened on Tuesday. Then I read through the logs up until 10 o'clock in the morning on Wednesday, because that's the point in time that it was still good. So I have to apply all the pieces to get through that. Does that make sense?
Yeah, I was thinking it's two are different, entirely different way of doing things.
Yeah.
One is you just back up all the data, as data, and then push it in, insert it into the tables, that's one thing.
Yeah.
And this is,
But again, different options are faster than other ones. So, as our usual, it depends. Okay? And then you have the, as the note here says, right, we have, do we allow updates to the database while we're backing up the data? Because then I could be out of sync in some things. So, the idea is that we have lots of different scenarios that we ultimately have to look at for this. Right? So, we talked about views, right? So, we had views without updates and views with updates, right? So again, views helped us do what? Protect ourselves, right? So again, the example, right? So this could be the example that gets us away from the idea of the backups. If everybody is using a view, which is a temporary version of it, I can do a backup because nobody's accessing it. So, or we can create the view only and have that only available when we're doing the backup period. So there's different ways that we can apply that as well. So views were around security, and it's also around speed, because we said doing all those wonderful joins and stuff, it takes a really long time to create the instance. I don't want everybody using 45 minutes of their time to do the queries. I want to create a view that everybody's going to use for that particular day or whatever. Right? So managing to those. All right? So, let's talk about your exam. Because I'm sure you want to know what could possibly be on the exam. So, what do you know for sure?
SQL, SQL.
SQL is going to be on there, right? Right? So again, I'm not necessarily going to ask you to be fluent in SQL and write a bunch of stuff. But what I would expect to be able to do is if I give you some SQL that you're able to tell me what it's doing. Okay?
So basically, we're identifying it, we're not actually gonna write it?
I am not going to ask you to write specifically SQL. But given something about SQL, you better be able to explain it. Okay? So if I was to give you a SQL statement, you should be able to tell me what it's doing. Okay? So select asterisk is going to tell me what?
Get some stuff.
Give me, give me some stuff isn't going to give you credit, right? but it gives me all of the columns. Right? If I have count asterisk, it's gonna say total up the number of records. Right? If I have in the from multiple tables or relations, I'm doing a join. Okay? If I have multiple queries, nested queries, you need to be able to tell me whether it's how it works. Right? It's giving me all of the data values because I have a in clause. Right? So the nested SQL is going to do a select, is going to give me the values to compare against that are going to cause me to, right, so my subquery is going to get the values that the outer query is going to look at. Okay? The corollary subquery where for every one on the outside I'm doing the, for every one on the inside I'm doing the outside one, right? So, okay. So again, given a, right, or cascade, what does cascade do? It applies it to multiple things. So if I do a cascade delete, it's going to cascade the one delete statement across all the other ones that have matching keys. Right. So stuff like that. Right. So again, I'm not going to say, I want you to write a query that's going to do X, Y, and Z, and then you physically write that. Right. What I'm going to do is expect you to be able to describe for me what SQL is, what are the types of things that are in it, given a statement, be able to describe what it is, what are the characteristics, so what's the difference between a group by and an order by, something like that, right? So, okay, so certainly SQL, we spent like 2 or 3 periods on that, so that's clearly, you know. What else do you know is going to be on there?
Constraints.
The normalization, right? That's why you're doing it before the exam, right? So, right? And what are you going to have to do? Exactly like the assignment, right? Given a relation that is poorly designed, to go through the normalization process, right? So it's probably going to be, the first question will be, what are the normal forms, first 3 normal forms? And then the second one is, do them. If I was to guess. Okay. 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 What is denormalizing or unnormalizing, and why do we do it? Yeah, we're going backwards, but why?
Too much structure.
Too much structure, because breaking it down too far means, right, there's extra overhead in doing every action. So you have to move backwards sometime because you need to be efficient in the way that you are doing things. Okay? Okay, so how many different types of joins are there, Cooper?
Inner, outer, full.
There's 4. Excellent. Right? So,
Inner, outer, full, left, right? No, because inner is left, right. Yeah, I got it right.
you have inner,
For the join.
left outer, right outer, full. Okay, so what is the left, right, and full do? So, you know it would never be just list the 4 kinds, right? You know that, right? So what does the left and right and full do? It gives all the data fields in the match, right? Okay, and if it's not, if there isn't a match, it gives the null values, right? So when it matches, it gives you all the data fields. If there isn't a match, there's going to be nulls, and it's based off of either the left table or the right table is the full domain that we are dealing with. And what's full? where you have all the entries of both tables and you can have nulls on either side. Okay. All right. What about the hierarchy stuff? When would I use a hierarchy versus a relational? Or big data versus relational or hierarchy? What does it depend on? The data, right? What is the structure that your data has? And you should mimic that in the database management system that you're going to build. All right, so obviously we've talked about the commit, the rollback multiple times, unit of work, right? So again, you should be able to describe all of those things over and over again, right? Okay, we talked about the different file organizations that we have, right? So index, direct, kinds of things, right? So, right, what are all the things that go into the database log? All the actions that happen before and after images, right? So you should be able to describe for me if I say, tell me about the database log and how's the database management system use it, right? Okay. We talked about batch versus online types of processes, right? Okay. We talked about all kind of these indexes, the views, right? I don't know. Anything else we talked about?
Nope.
She already's got that one on there, so thanks. Too late, Cooper.
Sorry, guys.
Give it a hashing function, where would it go, blah, blah, blah. Okay, so format's the same. You're gonna be tired of writing at the end like you always were last time. You're gonna cry, it's okay. Okay, so do you have any questions about what? So, anything we talked about, anything I think we talked about, anything I talked about in the database class, whatever the last one was, when I covered database kind of stuff in his system design class, if I think about it, I add it, right? We've talked about all this kind of stuff before. You're an expert at it. If you have any questions, he's there to answer it. Yes, Mark?
The assignment, what format should we put those first normal form, or the first, second, third normal forms in?
Make it look just like the other one.
Just look at it.
Okay. So
Do you
in
want us
the
to like draw connections in between the foreign keys, things like that, or?
dash line under the foreign key should tell me that it's a foreign key.
Okay.
So don't draw the lines all over the place and stuff, right? Underline means primary key. Dashed underline means it's a foreign key. And I better find that as a primary key someplace else. So you just list in a relation name, inside parentheses, the attributes, underline, dashed underline, good enough. Okay? So, that is due on Monday, and then I give you my version of the answer on Tuesday, 2 minutes before class, or before the exam. No, kidding, right? Okay, again, there are multiple ways to do this based on your assumption, so don't panic if yours doesn't look exactly like mine. Okay? Yes, Cooper?
How many points is it worth?
I don't know. How many would you like it to be worth?
4.
4? No.
It's worth a shot.
Maybe 4 times 10. But I could make it worth,
50 points would be cool too.
I could make it worth 50 and all or nothing.
When will the assignment be up on Canvas?
Throw it out there. You made me do it while I was standing up here. Don't you remember? Oh, you weren't paying attention, you were playing games on your laptop.
So, wait, hold on, I have a follow-up question. When will the assignment part be created under the assignments tab in Canvas so that I know how many points it is and when it's due?
It's due on Monday. It's worth 40 points.
I couldn't turn it in right now, for example, unless I emailed it to you.
I will put it out there before I leave.
Thank you.
How's that? Do you know you're exhausting?
Yes.
Anybody tell you that? Okay, just making sure. Kendra's told me that about you both. Just kidding. You really haven't. All right, if you have any questions, please email me with your questions. I'd be more than happy to answer those. You know what you're getting yourself into and next time, so it'll be fine. I will put it out there right now, sir.
The evaluation, should we be, that needs to be submitted today, should we be evaluating ourselves too?
Yes, you are evaluating you, every member of your team, and then the team as a whole.
So, not the ones up. I'm reading out Julio's contribution requirements, and Mike just said he hadn't heard back, so he doesn't.
No, those are fine.
Perfect, good. Thanks.
Yeah. Sorry about that. I'm guessing it's sitting in my draft folder.
We've been moving forward with them, so we're good.
Great, how are you, sir? Okay, now who are you working for?
I'm in the same team as the
Yeah, the two of you together.
Yeah.
All you need is like, the rest of you guys.
You know, trying to get Robin there.
Yeah, that's like, there's no reason to flag that.
The person I had was just about the management, the exam is not management. Like when you can go on.
Yes, yes, I sent a note to Joe and it hasn't been changed yet. It's going to be changed probably tomorrow.
No, we talked about.
They have to schedule around. Yep.
Yes.
All right, thank you.
So what would you call that? That diagram? the stuff that you put DAO, all that.
Oh, I like that.
What would you call it?
It's just a software diagram.
Software.
But it's similar to the 3C
Right.
architecture, but it just makes it
Just
smaller.
for the email, I wanted to make sure. I just couldn't remember what it's called. Cool.
Laters.
Yeah, that's a good point, at least we have basically knowledge of each other.
I want the parts of this that you put down, I want you to feel comfortable with how it's documented in like.
Yeah.
Like what you would like to see reflected there, either, section parts of it out. But, we just want to make sure. It's
Oh, yeah, this is
kind of
what
got
you want
pieces
to go
that
on.
mirror what's on the back. And so it's just one of those things that I don't know, I want to make sure that we're talking about it, saying, hey, we did this. Right, you know what I mean?
Yeah, I heard that.
Right, so I'm not saying like, oh, go put together like a general documentation section, I'm just saying like, there's something you feel like is missing, things that you'd like to,
I know it
make
is
notes in it.
important, I'm not
If you want to put in a couple of things for free,
Yeah,
maybe Sundays, those times,
to
touch base, make sure that's passed, so.
This
So,
is,
yeah,
because,
it's no problem.
because the, we be still, I thought since they changed the features, so way different.
Yeah, but like.
Okay, I'm
Yeah, whatever you want.
Okay, well, it's the same, the last thing.
But again,
There are all
you've done a ton of work, and so like, I want you to,
already mentioned the syllabus.
you know, so if we can offer
Or
something
he
that
on
can
the
make sure,
surface syllabus.
I guess,
but
use your
not
judgment,
change.
you know, but like, and use your judgment and everything.
Is he saying only bring that to
I think I'm pretty good right now. The search thing, like, I was gonna have to ask you anyways, but like, I wasn't, so, a lot of that stuff,
makes sense.
yeah, that was meant to be just a note to me. So like, don't feel free, or don't, like, if you look through and things don't make sense, I'll let you know if there's like a specific question. You hit something that I was gonna have to ask anyways. so-
Sorry, I
or
was like,
you
I hope
know-
I'm not overstepping.
No, you didn't, like, I was gonna have to ask it, but it might have seemed like the comment, like, it didn't make sense, or whatever, but it was just to me.
I was like,
Just,
no,
you know.
you probably were just a speaker, and I was just like, oh, I don't know.
No, it's fine, and feel free, but just so
I
you
think,
know,
yeah,
that's
disregard
why.
or you were just like, yeah, but it's available.
Well, I think I basically just kind of.
But yeah, it is the same thing, right?
Because I hadn't had a
And
chance.
they- and then also.
And in fact, I just, it was good. It was my first.
And if you look through any of the documentations on the top,
It's more,
just check yourself.
there's a lot of visualization. I
No,
can
you're
never
not-
do that, I don't want to ever cause it, so.
No, you're not overstepping anything.
Keep letting me know, so we do knowledge.
Yeah. And then just adding I'm just kind of like testing
Yeah,
stuff
right.
here and there, like, and
So-
walking through what
He
you
wants
actually
to
are
check.
testing. Is that way, because there's some certain parts that work there, which is fine, but like, just testing the stuff that I can get.
Almost the same, it's okay, it's okay, it's fine, that's me. That way, I think it's pretty much the extra push, like, yeah, we're talking about this.
So we don't have to do it. Yeah, like, here's something from like back here.
I was saying you do things for
Just
natural
now, I
example.
think I just need to, are you cool with me pushing?
Yeah, you
first?
send me.
Okay, so, because he
Yeah,
has.
I was using his here for that.
Not really, he didn't mention that.
I'm sure it works great, and I just need